A very good day, my dear students. I am Nishant. I am a motivational and aptitude trainer. I work for freelance, and I would like to recognize myself as a social entrepreneur. It gives me immense pleasure to be a part of this novel initiative of developing modern e-learning tools by Guruji.net for the sake of student community. And I strongly believe that my contribution would be significant by this course in quantitative aptitude and training, especially for the pre-final year and the final year students who are preparing themselves for placement interviews. So what is quantitative aptitude? Why is that the quantitative aptitude gains so much significance, especially in the context of placement interviews and in higher competitive exams for higher education? Quantitative aptitude indicates the problem solving skill of any individual. The quantitative aptitude reflects your problem solving skills, how good you are solving at problems, which is the basic quality which a recruiter or the community in a higher research environment expects from you. So there are many modules which comprises quantitative aptitude, and every day new testing tools, new testing methods and new topics are emerging in the area of quantitative aptitude. But however, there is a certain set of foundational approaches for quantitative aptitude, a certain set of basic concepts in which, if we are clear, if the ideas are clear, then you can confidently approach towards advanced concepts and any type of new problems. So in that context, today we'll have a small session on number theory. We'll consider number theory as our module 1. The world of numbers. The numbers are classified in different ways. There are many types of classification in numbers. For example, consider natural numbers, whole numbers and integers. So what are natural numbers? Any number, 1, 2, 3, 4 till up to infinity are called natural numbers. What are whole numbers? Natural numbers along with 0 is called whole numbers. So all the natural numbers are whole numbers except 0. What are integers? The set of all positive and negative numbers ranging from minus infinity to plus infinity are called integers. So in this set of integers, what are called as positive integers and what are called as negative integers. So this set starting from 1 to infinity is called as positive integers, and this set ranging from minus infinity to minus 1 are called negative integers. Then what about 0? 0 is neither positive nor negative. So this ranging from minus infinity to plus infinity are the set of integers, and from 1 to infinity it is known as positive integers. From minus infinity to minus 1 they are called as negative integers, and this 0 is neither positive nor negative. So from this we can enter into another fact: signed numbers and unsigned numbers. What are signed numbers and unsigned numbers? Any number without a sign, that is indicating only about the magnitude or the absolute value of the number, are called as unsigned numbers. What are called as signed numbers? The numbers with a sign in front of them which indicates whether they are positive or negative. Such numbers are called as signed numbers. And another very common type of classification of numbers is even and odd. Even and odd. What are even numbers? Any number which is divisible by 2. When divided by 2, if the number gives a remainder of 0, they are called as even numbers. What are called as odd numbers? The set of all even numbers subtracted from the set of all whole numbers are called as odd numbers, usually mathematically represented as 2n plus 1, where n is equal to ranging from 0 to infinity or 0 to infinity. Any number divisible by 2 which gives a remainder 0 are called as even numbers, and all the other numbers belonging to the set of whole numbers, subtracting the set of even numbers gives you the set of odd numbers. What about 0? 0 is an even number. So we have come across two properties of 0. 0 is neither positive nor negative, but it is an even number. And the very common fact, what are the different types of operations that are performed on numbers? As usual, addition, subtraction, multiplication and division. These are the very common, or any complex operation will consist of these operation on numbers. So once again, regarding the properties of 0, any number, say a, added with 0 will be the same number. Any number multiplied by 0 will give you 0. Any number divided by 0 is undefined. Another different type of classification, or another different category of numbers, is the prime number and the composite number. What are prime numbers? Any number greater than 1. Any number greater than 1 which has only two divisors, two factors. So any number greater than 1 which has only two factors or divisors. And among these two divisors, for example, consider a. The number, if the number a needs to be a prime number, it must be greater than 1, condition number 1, and it should have two factors, among which one factor is the a itself and another factor is 1. A number satisfying these two conditions is said to be a prime number. For example, consider 2. So 2 is greater than 1. It has two factors, 1 and 2. The number itself. So 2 is a prime number. Consider 19. 19 is greater than 1 and it has two factors, 1 and 19. So 19 is a prime number. Some of the common prime numbers which you should be familiar with is 2, 3, 5, 7, 11, 13, 17, 19 and 23. Commonly used, or the prime numbers which you commonly come across. And a very interesting fact once again here is 2 is the only even prime number. 2 is the only even prime number. None of the other prime numbers are even. What are called composite numbers? So the numbers excluding the prime numbers, all the other numbers are said to be composite. So 1 is a composite number. 4, 6 or any such numbers are called composite numbers. Another two important facts that are associated with the numbers is the highest common factor and the lowest common multiple. Highest common factor, most of you would have come to it. Highest common factor. Highest common factor, usually known as HCF. What are the other names for highest common factor? Greatest common measure, that is GCM, or greatest common divisor, GCD. HCF, GCD, GCM all have the same meaning. Next one is the lowest common multiple, LCM. We'll see that later. What is highest common factor? So highest common factor of any two numbers is the greatest integer which is a factor of both the numbers. Consider two numbers a and b. What is the HCF of a and b? HCF of a and b is the greatest integer which is a factor of both a and b. Say 2 and 6. You need to factorize 2 once and 6, it is 2, 3. So 2 can be represented as 2 into 1 and 6 can be represented as 2 into 3 into 1. The common factor. So 2 is the greatest integer which is a divisor of both 2 and 6. So 2 is the highest common factor of 2 and 6. Consider 16 and 25. So you need to factorize 16. It can be represented as So 16 can be represented as 2 into 2 into 2 into 2, and 25 can be represented as 5 into 5. So is there any common factor between these two numbers? No. So it represents that these two numbers are distinct. They do not have a highest common factor. What is called as lowest common multiple? Lowest common multiple of two numbers. Let us take A and B. What is the LCM of A and B? The lowest common multiple of A and B is the smallest integer which is a multiple of both the numbers. You take for example 2 and 6. 2 into 3 is equal to 6 and 6 into 1 is equal to 6. So 6, a number appears in, is a multiple of both 2 and 6, and it is the first or the smallest common multiple of both 2 and 6. So LCM of 2 and 6 is 6 for any number. There is a shortcut method. For example 20, you take 24 and 32. What is the LCM of 24 and 32? You can go for the L division method straight away. Take do prime factorization. So to find the LCM of two numbers, say 24 and 32, you need not go for separate division, prime factorizing 24 and prime factorizing 32. Instead you can take a single L division, prime factorize and multiply all the common factors. So this gives you the lowest common multiple of 24 and 32. What is the significance of finding HCF and LCM, the highest common factor and the lowest common multiple of two numbers? Let us consider two numbers 2 and 6. What is the highest common factor of 2 and 6? It is 2. Obviously the highest common factor of 2 and 6 is 2. What is the LCM of 2 and 6? If you are doing by L division method, it is 2 into 3, 6. Now multiply the highest common factor and the lowest common multiple. You get 12. So can you find something interesting between the product of the HCF and the LCM of 2 and 6? The product of the two numbers 2 and 6 will be equal to their product of HCF and LCM. So this is a numerical significance in mathematics. You may apply this concept in a number of problems. There are a number of formulas related with number theory which have their background in algebra, or there are n number of formulas associated with the number theory, but very important and commonly appearing formulas are like finding the sum of n natural numbers, finding the sum of n cube of the natural numbers. For example, finding the sum of n natural numbers 1 plus 2 plus 3 up till n. That is, it is given by the formula n into n plus 1 by 2. So n into n plus 1 by 2, this particular formula is used to find the sum of n natural, consecutive natural numbers. And to find the sum of the squares of consecutive natural numbers, say 1 square plus 2 square plus 3 square up till n square, the formula is n into n plus 1 into 2n plus 1 by 6. And the formula for finding the sum of cube of n natural numbers, 1 cube plus 2 cube plus 3 cube up till n cube, is nothing but the square of this particular formula, that is n into n plus 1 by 2 the whole square. So these are some of the common formulas which will be very helpful in solving a number of problems. Another very significant concept in number theory is the divisibility and the test for divisibility. What do you call as the divisibility and the test for divisibility. Now, what kind of numbers are divisible by 2? Any number which is an even number. Any number which is a even number is divisible by 2. Any number which is an even number is divisible by 2. So what are even numbers? Any number which ends with 0, 2, 4, 6, 8 are said to be even numbers. So those numbers will always be divisible by 2. So this is known as the test for divisibility by 2. And for 3, that is so this is the test for divisibility by 2. What is the test for divisibility by 3? That is the sum of all must be divisible by 3. The sum of all the digits in a given number must be divisible by 3. For example, 729. Sum of all the numbers. 7 plus 2 plus 9 is 18. 18 is divisible by 3. 18 when divided by 3 gives you 0. So 18 is said to be divisible by 3. What is the divisibility test for 5? Any number ending with 0 or 5. If the last digit of the given number is 0 or 5, it is said to be divisible by 5. For example, 50 or 55. These are divisible by 5. These are simple divisibility tests. What is the divisibility test for, say, 4? That is the last two digits must be divisible by 4. That is the last two digits of the given number divided by 4 must be 0. Then the number is said to be divisible by 4. Say for example 7,228. 7,228. Is it divisible by 4? So how to check whether the given number is divisible by 4? Consider the last two digits alone. 28 when divided by 4. 4 sevens are 28, 0. So this number, when the last two digits are divisible by 4, the whole number is said to be divisible by 4. So this is a divisibility test for 4. Similarly, for the number 8, the last three digits must be divisible by 4. Last three digits must be divisible by 8. Example, consider the number 1720, that is 1720. Is it divisible by 8? In order to check it, consider the last three digits, 720. So 720 when divided by 8 gives you 90. So the whole number 1720 is said to be divisible by 8. Similarly, for number 6, what is a divisibility test for 6? A number must be divisible by both 2 and 3. If a given number is divisible by both 2 and 3, it is said to be divisible by 6. For example, say 12. 12 is divisible by 2 as well as by 3. Hence, it is divisible by 6. What is the divisibility test for 12? If a number is divisible by 4 as well as if the number is divisible by 3, then the number is said to be divisible by 12. Consider 48. 3 16s are 48, 4 into 12 is 48. So the 48 is also a multiple of 12. What is the divisibility test for 9? The sum of, it is similar to the test of 3. The sum of all the digits in a given number must be divisible by 9. Then the number is said to be divisible by 9. What is the divisibility test for 10? Simple. The last digit must be 0. And an interesting divisibility test is for 11. Now say consider 121. How will you find the number 121 is divisible by 11? You need to separate out the digits at the odd places. That is 1, 2, 3. So separate the digit at the odd places 1 and 1. Find the sum. 1 plus 1 is 2. Similarly, separate the digit found in the even position. That is, here it is simply 2. Find the difference between the sum of the digits at the odd position and the sum of the digit at the even position. If the result is 0, or if that particular number is divisible by 11, then the given number is said to be divisible by 11. For 121 it is easy. Say for example 1331. What are the odd position numbers? 1 and 3. 1 plus 3 is 4. 3 and 1 even position numbers. 3 plus 1 is 4. 4 minus 4 is 0, and hence 1331 is divisible by 11. What is the divisibility test for 25? The last two digits must be either 00 or 25 or 50 or 75. For example, is this number divisible by 25? You need not divide it to find. Consider the last two digits, it is 50. If the last two digits is 00, 25, 50 or 75, then the whole number is said to be divisible by 25. So we have seen the classification of numbers, the various categories of numbers, examples in them, the two factors, the highest common factor and the lowest common multiple, and their significance, the various divisibility tests. Another important or interesting concept in number theory is the exponent and roots. Any representation in the form of a power b or a power m, let us say a power m. A is said to be the base and m is said to be the exponent. We call it as a power m. A is said to be the base and m is said to be the exponent. Okay. And these exponents have certain properties. For example, what is 2 power 3? 2 power 3 is nothing but 3 times 2. 2 power 3 in the sense multiplying 2 3 times, that is 8. Base is 2, exponent is 3, the result is 8. The original value is 8. So what are the properties associated with it? Let us consider a power m into a power n. When the base are same and the exponents are different, and if you are multiplying both of them, the result will be the addition of powers. A power m into a power n is equal to a power m plus n. Similarly, a power m divided by a power n will be a power m minus n, and a power m whole power of n. A power m whole power of n is a power m n. M into n, a power of m into n. Similarly, a power m into c power m. In this case, powers are same but the base is different. What is the value? A into c whole power of m. For examples, a power m into a power n, that is 2 power 3 into 2 power 2 is nothing but 2 power 3 plus 2 is equal to 2 power 5 is equal to 32. So 2 power 3 is 8, 2 into 2 is 4, 8 into 4 is 32, which is same as the given formula. 2 power 3 divided by 2 power 2 is nothing but 2 power 3 minus 2, which is nothing but 2 power 1 result is 2. 8 divided by 4 is 2. 2 power 3 whole power of 2. You need to multiply 3 into 2. 2 power 6. What is 2 power 6? 64. Nothing. 2 power 3 is 8. 8 square is 64. So that is what we obtain in this manner. And similarly, when the bases are different, you can find the product and then apply the powers. 5 power 2 into 2 power 2 is nothing but 5 into 2 power 2, that is 100. 25 into 4 is 100, and that we have applied in this method. Okay. And now comes again our 0. What is the value of 0 power something? The value of 0 power anything, any positive number. 0 power any positive number is always 0. What is the value of 0 power any negative number? 0 power any negative number will be undefined. What is any number, positive or negative number, to the power of 0? It will be always 1. Another concept is the squares and the square root. What do you mean by squares? If you are that is the power, if the power value is 2, say for example 3 power 2, it is pronounced as 3 square. So 3 power 2 is 3 into 3 is equal to 9. 3 square is 9. So they are called as squares. What are square roots? For example 25. What is the square root of 25? It is nothing but 5 into 5. Square root of 5 into 5. So plus or minus 5. The result of square root of 25 will be plus or minus 5. And in this we have two values, minus 5 and plus 5. Plus 5 is called as the principal square root. Plus 5 is called as the principal square root of a given number. And it has more significance than minus 5. Usually we consider plus 5. What is the square root of 0? It is 0. And there is a method. Now we will have a small trick. To find the square root of any number which ends with 5. To find any number that ends with 5. What is the method? You need not go for your classical multiplication. 25 into 25. Just multiply 5 into 5 is 25. Write as it is. Now you have the number 2. Increment 2 by 1, that is 3. So 2 into 3 will be 6. So you obtain the value 6. So this is a shortcut method for finding the square of any number that ends with 5. For any big number, you consider 95 into 95. Just write 25. Now you take 9, increment it by 1, 10. 9 into 10 is 90. So you add the value. So 95 into 95 is 9025. There is an interesting factor which is associated with square roots. Now I let you say, for example, 2. It is clearly identifiable that 2 is a prime number. 3. It is a prime number. 21. 21 is not a prime number because it has factors say 3 and 7. 3 into 7 is 21. So it is not a prime number. But what happens now, for example, a larger number is given, say 191. When 191 is given, how to identify whether it is prime or it is composite? Now find a perfect square that is associated with 191. Now say 196. 196 is a perfect square, that is 14 into 14 is 196. So 14 is greater than root of 191. So when a number is given, find the nearest perfect square, and that perfect square will be greater than the root of 191. Now list all the prime numbers that are less than 14. 2, 3, 5, 7, 11, 13. Check whether 191 is divisible by these prime numbers. It is not divisible by 2, 5. Obviously it is not divisible by 2 and 5 because it is not an even number. It does not end with 0. Now for 3, apply the divisibility test. 1 plus 9 is 10, 10 plus 1 is 11. So 11 is not divisible by 3. So the number is not divisible by 3. And 7, 7 2s are 14, it is also not divisible. 11, it is not divisible. 13, it is not divisible by 13 also. And since it is not divisible by any prime number that is less than 14, 191 is a prime number. We can with certainty we can state that 191 is also a prime number. You can apply this method to any larger number also. We have come across various properties of 0. Let us summarize what are the properties of 0. As I said, 0 is neither positive nor negative. 0 is an even number. Any number added with 0 will be the same number. Any number multiplied by 0 will give you a 0. So 0 is neither positive nor negative, but 0 is a even number, and a plus 0 is a multiplied by 0 is 0. 0 power any number, a is always 0, or 0 power a is 0. Any number to the power 0 is 1. Any number to the power 0 is 1. So these are some interesting properties of 0 which we should be very clear with. We had a short discussion on the very basics of number theory, the classification, the prime numbers and the method of finding the prime numbers, the divisibility test, the exponents, the squares and the square roots, and I think 1 or 2 shortcut methods also. We'll have a discussion on around 5 to 6 problems just to acquaint yourself with what is number theory or what kind of problems may be found in number theory. Number theory itself is a very vast area of in quantitative aptitude. You will have number of problems or number of methods in which these problems may be put in front of you. At the end of all the modules, we'll have a separate session on what are the commonly appearing types of questions in number theory that we can expect in placement exams or in any other higher competitive exams. So in order to just acquaint yourself, we'll have some interesting as well as important problems in number theory. This is a very simple problem. The sum of first 100 natural numbers is divisible by. The choices are 2, 4 and 8, 2 and 4, 2 only. Now the sum of you can find the solution from for this problem directly from our discussion, because the sum of first 100 natural numbers, you have a formula for finding the sum of n natural numbers, and to check the divisibility we have learnt about divisibility test. So to find the sum of n natural numbers, the formula is n into n plus 1 by 2. N into n plus 1 by 2. N represents the number of natural numbers that we are going to add, or the last term. Since it starts from 1 to 100, n is 100. 100 into 100 plus 1 by 2, which is 50 into 101. 2 you can cancel out with 100, it is 50. 100 plus 1 is 101. 50 into 101 will be the sum of first 100 natural numbers. Now multiply 50 and 101. It is very easy. 5050. Just multiply by 5. It is 505. Add a 0. 5050. Now to check with the choices, since the last digit is 0, it is going to be completely divisible by 2. So it is divisible by 2. Is it divisible by 4? What is the divisibility test for 4? Consider the last 2 digits. 50. Is 50 a multiple of 4? No. So the number is also not divisible by 4. Now to check whether it is divisible by 8. Consider the last 3 digit, that is 050. Is 050 in the sense it is 50. Is 50 divisible by 8? No, 50 is not a multiple of 8. In that case, this number is only divisible by 2. So the choice is C. Here's another problem. A number divided by 36 gives remainder 19. What is the remainder when it is divided by 12? Here the number is unknown. You can keep the unknown variable as say x. When x is divided by 36, you get some quotient and the remainder is 19. When x is divided by 36, you get some quotient and the remainder is given as 19. A shortcut in this is x can be represented as x is nothing but 36q plus 19. That is, in order to obtain the dividend, you need to multiply the divisor and the quotient and add it with the remainder, you will get the dividend. So x can be represented as 36 into quotient q added with the remainder 19. So x is equal to 36q plus 19. Now you are dividing the same number by 12. That is, you are dividing x by 12. What would be the remainder? Let us divide x by 12. X by 12 is nothing but 36q by 12. Now 36q plus 19 by 12 can be written as 36q by 12 plus 19 by 12. I hope this would be clear. A plus b by c is nothing but a by c plus b by c. So 36q plus 19 by 12 is 36q by 12 plus 19 by 12. 36 is a multiple of 12. Any number multiplied by 36 will also be a multiple of 12. So the remainder will be 0. Remainder will be 0 for this particular part. What about this part? 19 divided by 12. The remainder will be 7. The 19 divided by 12 is 7. So 0 plus 7 is 7. So the choice is 7. So A is the right choice. A number is divided by 36. The number is unknown. Let us keep the unknown number as x. X is divided by 36. We get a quotient and the remainder is 19. There is a method for representing the dividend given the quotient, divisor and the remainder. X is equal to 36q plus 19. Multiply the divisor and the quotient added with the remainder. It is given in the problem what is the remainder when it is divided by 12. You are dividing the same number x by 12. So here it applies to the right hand side also. It is you are dividing by 12. As per the laws of fraction, you can separate it into two parts. 36q by 12 plus 19 by 12. 36 is a multiple of 12. Any number multiplied by 36 will also be a multiple of 12. So the remainder will be 0. And 19 divided by 12, the remainder will be 7. The answer choice is 7. Finds the product of consecutive integers starting from 20. How many numbers must he add in order to get a result with 3 zeros at the end? So the person is starting from 20 and he will be multiplying consecutive integers. Consecutive integers in the sense 21, 22, 23 and so on. So he will be multiplying 20 into 21 into 22 up till some numbers, up to certain times, till the result contains 3 zeros at the end. When will you have 3 zeros in your result? When you multiply 10 3 times. 10 into 10 into 10 is 1000. Now 10 can be 10 into 10 into 10 is 1000. 10 can be factorized as 5 into 2. So multiplying 5 into 2 3 times will also give you 1000. Or multiplying 5 3 times and 2 3 times and multiplying their product will also give you 3 zeros in your result. Now, so in your process of multiplying, finding the product of consecutive integers starting from 20, you need to come across multiplying 5 3 times and 2 3 times. So 20, what is the factor? 5 into 2 into 2. You have come across 1 5. You have to come across another 2 5s. So 21, it does not contain 5 as a factor. 22, 23, 24. and come for 25. 5 into 5. So if you multiply 20 into 21 into 22 into 23 into 24 into 25, you will come across multiplying 5 3 times. Our first condition is satisfied. Now we have to come across multiplying 2 3 times. In 20 itself you have come across multiplying 2 2 times. So another 1 2 is required. Is there 2 as a factor in 21? No, because 21 is not a multiple of 2. But 22, it is 11 into 2. We have 2 as a factor here. So by multiplying 20 into 21 into 22, you have come across 3 2's. So let us take the maximum, that is 25. In order to satisfy both the condition, you have to multiply consecutive integers starting from 20 till 25. 20 into 21 into 22 into 23 into 24 into 25 will give the desired result with 3 zeros at the end. So how many numbers are there? 21, 22, 23, 24, 25 and 26. 6 numbers are there. So the answer choice is C. So the concept of HCF, the prime factorization and the concept of divisibility test, everything comes in such type of problems. Given the numbers 2, 3, 5, 7, you need to form how many numbers can you form with the given digits that are divisible by 25. You need to remember the divisibility test for 25. Any number that ends with 0, 0, the last 2 digit must be 0, 0 or 25 or 50 or 75. Then they are said to be divisible by 25. Now, using these 4 numbers, you cannot have 0, 0 or 5, 0 at the last. If any number has these 2 digits at the last position, at the ones and tens position, then the number is said to be divisible by 25. With these given 4 numbers, you cannot form any number ending with 0, 0 or 5, 0. You can form only numbers that are ending with 25 and 75 that are divisible by 25. So how many numbers can you form? 20, 37, 25. Interchange 73, 25. So this is 2 possibilities. And ending with the 75, you can either have 23 or 32, 75. So using these 4 numbers, these are the only 4 possibilities that you can form such that they are divisible by 25. So answer choice is not given. The answer is 4. You can form 4 numbers. Many of the mathematical operations or process may be cumbersome, but there are many available shortcut methods or tricks in which you can arrive at the solution at a faster pace, even with very simpler computations. As we saw earlier, for example, finding the square of a number ending with 5. So 35 into 35. Step 1, multiply. Just place 25 here, take the number 3, increment it by 1, that is 4, find the product of these 2 numbers, it is 12, place 12 here. So this is a very simple method for finding the square of the 2 numbers ending with 5. You need to find 12 into 11, multiplying a 2-digit number by 11. Instead of going traditionally, place 1 as it is and 2 as it is. Add 1 and 2. 1 plus 2 is 3. Place 3 between 1 and 2. This gives you the product of multiplying 12 by 11. For any case, 35 into 11. Place 3, place 5 as it is. 3 plus 5 is 8. Place 8 in between 3 and 5. So 385 is the product. What happens for 99? 99 into 11. Place 9 as it is. 9 plus 9 is 18. Should not place 18 in between 9 and 9, place 8 and the remainder is 1. Carry 1 over to the next number. So 9 plus 1 will become 10. Carry 1 to 9, so answer will be 1089. So, and for 3-digit numbers, Say for example 135 into 11. Same process, place 1, the last number as it is, place 5 at the end. 1 plus 3 is 4, 3 plus 5 is 8. So within a single step you can arrive at the final solution. Place 1 as it is, 5 as it is, 1 plus 3 is 4, 3 plus 5 is 8. So 135 multiplied by 11 will be 1485. For example, a larger number, 999 into 11. Place 9 as it is, the first number, last number as it is. 9 plus 9 is 18. So place 8, carry over 1 to this number. 9 plus 9 is 18. Place 8, carry over 1 to this number. So 9 plus 1 is 10, 8 plus 1 is 9, 8, 9. So the final answer is 10989 is the solution for this. Okay. Now for multiplying numbers, say 28 into 22. Now just observe this. If you are going to multiply two numbers with the same figure in the 10th position and the number digits in the ones position adds up to 0, 10. For example, 2 and 2. It is the same here. And 8 plus 2 will add to 10. In numbers like this, that is 28 into 22 or 35 into 35 or 46 into 44. Here the first digit is same, 2 2 3 3 4 4, and the remaining digits adds up to 0. 8 plus 2 is 10, 5 plus 5 is 10, 4 plus 6 plus 4 is 10. In this case, just multiply these two digits. 8 into 2 is 16. Have the number 2, increment it by 1, that is 3. 2 into 3 is 6. So 616. You can check it out for 35. In our first shortcut method, just place 25 because it is a square of the same number ending with 5. Place 25, have 3, increment it by 1, 4. 4 into 3 is 12. In this method, 35 into 35. Multiply 5 into 5 is 25. And as it is, they are same. Have 3, increment it by 1, 4, 12. 12, 25. We'll have another trick. To subtract any number from hundreds, thousand or 10,000, that is from any powers of 10. For example, if I want to subtract 972 from 1000, we can use the rule all from 9, last from 10. You need not keep borrowing or doing other operations. Instead, just start directly from 9. Subtract 9 from 9, 0. Subtract 7 from 9, 2. Subtract the last digit only from 10. 10 minus 2 is 8. So 28 is the answer. For example, you need not keep borrowing. Instead, subtract 7 from 9. Answer is 2. Subtract 1 from 9, it is 8. Subtract 5 from 9, it is 4. Subtract 2 from 9, it is, the last digit should be subtracted from 10. So 8. So this is one method for finding the difference without borrowing or performing any other operation. Subtract everything from 9 and the last digit from 10. Subtract everything from 9. 9 minus 7, 9 minus 1, 9 minus 5. Last from 10. 10 minus 2 is 8.